In this video, we will practice some basic differentiation problems using the chain rule. These questions are useful for anyone learning differentiation, whether you are preparing for university exams, competitive exams, or simply strengthening your calculus skills. I will explain every step clearly so you understand the concept and can solve similar problems on your own. Let us begin. First question, 2x square plus 4 whole cube. Here, the whole expression is raised to the power 3. This is a perfect example of the chain rule. Let y is equal to 2x square plus 4 whole cube. First, differentiate the outer function. You know the derivative of u cube is 3u square. Now, keep the inside expression unchanged and write as dy by dx equals 3 into 2x square plus 4 whole square. Next, differentiate the inner function. The derivative of 2x square plus 4 is 4x. Therefore, into 4x. Finally, dy by dx equals 12x into 2x square plus 4 whole square. Very simple. Differentiate the outer function first, then the inner function. Next question. Ax square plus bx plus c whole raised to 1 by 3. Let y is equal to ax square plus bx plus c whole raised to 1 by 3. Again, we will use the chain rule. Differentiate the outer function. The derivative of u raised to 1 by 3 is 1 by 3 u raised to minus 2 by 3. So, dy by dx equals 1 by 3 into ax square plus bx plus c whole raised to minus 2 by 3. Now, differentiate the inside expression. Since a, b and c are constants, the derivatives of ax square plus bx plus c is 2ax plus b. So, into 2ax plus b. Therefore, dy by dx equals 1 by 3 into ax square plus bx plus c whole raised to minus 2 by 3 into 2ax plus b. That is our final answer. Next question. Cube root of a plus bx whole square. Let y equals cube root of a plus bx whole square. First, rewrite the cube root using exponents. Y equals a plus bx whole raised to 2 by 3. Now, differentiation becomes much easier. Differentiate the outer function. Dy by dx equals 2 by 3 into a plus bx whole raised to minus 1 by 3. Now, differentiate the inner function. The derivative of a plus bx is simply b. So, into b. Therefore, dy by dx equals 2 by 3 into b into a plus bx whole raised to minus 1 by 3. Always rewrite radicals as powers before differentiating. Fourth question. Y equals 1 by root of 3 plus 2x. Again, rewrite the expression using a negative exponent. Y equals 3 plus 2x whole raised to minus 1 by 2. Now, apply the chain rule. Dy by dx equals, differentiate the outer function. Minus 1 by 2 into 3 plus 2x whole raised to minus 3 by 2. Differentiate the inside function. The derivative of 3 plus 2x is 2. So, into 2. Minus 1 by 2 into 2, minus 1. Hence, dy by dx equals minus of 3 plus 2x whole raised to minus 3 by 2. That is the final answer. Let us solve one more question. This involves both the chain rule and the quotient rule. The outer function is raised to the power 4. So, we will first apply the chain rule. Differentiate the outer function. The derivative of u raised to 4 is 4u cube. So, dy by dx equals 4 into 2x plus 1 by x minus 3 whole cube. Now, we need to differentiate the inner function 2x plus 1 by x minus 3 using the quotient rule. According to the quotient rule, d by dx of u by v equals b into du by dx minus u into dv by dx by v square. Here, u equals 2x plus 1, v equals x minus 3, du by dx equals 2, dv by dx equals 1. So, dy by dx becomes 4 into 2x plus 1 by x minus 3 whole raised to 3 into b, that is x minus 3 into derivative of u, that is 2, minus u, that is 2x plus 1 into derivative of v, that is 1, by v square, that is x minus 3 whole square. Simplify, we get dy by dx equals 4 into 2x plus 1 by x minus 3 whole cube into minus 7 by x minus 3 whole square. Therefore, dy by dx equals minus 28 into 2x plus 1 whole cube by x minus 3 whole raised to 5.